Good afternoon, everyone.
Good afternoon, ma'am.
Okay, so in today's class, what we are going to do is we'll be designing our database using entity relationship model. So first, what we are, as I have already mentioned this, it is just like your software engineering means when you are about to design your software, what you need is you need to perform certain things like you need to collect the requirements. After that, using the requirement, you are going to get the documentation of the requirement, that is known as requirement specification. So here, same thing. You will means the requirement specification will be there. These things you can collect it, or the other people's means the peoples who are going to work on this database, they are going to collect it. And what by using the collected requirements information about the database, what will happen is the requirement specification uh, will be formed. Okay. And using the requirement specification, so you already know what is requirement specification, do you? It is a documentation. It is a documentation about the requirements. Okay, about a certain thing. It can be for a software or for anything that you are going to design. So using the requirement specification, you are going to means you are going to analyze the requirement specification. And then after analyzing the requirement specification for database, what you need to do is while analyzing the requirement specification, you have to identify the entities and their attributes, and at the same time you have to identify the relationship between this one entities along with the attributes that we can have for the relationship. Okay. So here in our case, what happened is the requirement specifications are already provided. Okay, the requirement specification will be provided to you, and you have to analyze it. And while analyzing it, while reading the requirement specification one by one, you have to identify the entities, their attributes, the relationship between the entities, and the attributes of the relationship. Okay, so let us see how we are going to do that. Here an example database is given, company database. So for this company database, we are going to design the ER model, means we are going to design the database for company. Okay. And that will be by using the ER model. So let us see the requirement specification. The first point, the company is organized into departments. Here, the whole thing that for which we are going to design is the company is going to be the whole thing, isn't it? Company itself is also an entity. Okay, but this entity we are not going to represent it by using the rectangles and all. Okay, so what we are going to do is we are going to identify the sub entities that forms the company, and the attributes of this entities that we have identified, and the relationship between the entities. And the whole thing, the whole diagram that we are going to get at the last at the last means at the end of this design. And that particular thing, the whole diagram is going to be representing the overall company entity. Okay, but you are not supposed to represent the company itself by using an entity, means the rectangle. Okay, I'm telling this because some of the students, when they are asked to design a database, what they do is they just means, for say for example, for company database, for this company database, company itself is also an entity, isn't it? They identify this company as an entity, and they represent it by using the ER modeling representation. Okay, but that is not the case. Company itself is the whole thing. Okay, inside this whole thing, the inside this company, whatever entities it has, we have to identify them. Okay, so you do not need to represent the company in your ER model, because the whole ER model, the whole ER diagram that you are going to get at the end will is going to represent the company. Okay, is that clear? Okay, then if it is clear, then let us try to identify the entities and the attributes of the entities. After that, we'll see what will be the relationship between the entities. Let us read out the first statement. The company is organized. The first statement: the company is organized into departments. From here, we can identify one entity, and that is the department entity. Department is going to be an entity type for the company database. Okay, so the first entity type is department. Okay, so as we have identified the department, so this one, I'll just add a new slide. So the first entity that we identify is department. Okay, now let us read out the second statement. Department has unique name, a unique number, and a particular employee who manages the department. Okay, so department has unique name, a unique number, and a particular employee who manages the department. So here, from this statement, we can identify many things. The first one is, there is going to be attributes. We already see here, unique name is going to be the attribute for the department entity type. Unique number is again an attribute for the department entity type, and the particular employee. Let us analyze this part later on. First, there is going to be two attributes for department from this statement. The first one is department number, and the department name, and the second one is department number. So let us add the attribute here like this. Inside parentheses, we can write the attributes. Okay, so entities can also be represented like this. So I will represent it using the name of the entity type and the name of the entity attributes of the entity type inside the parentheses. So department number. The first attribute for the department entity type is department number, and another one is department name. Okay, so let us see, is there any other attribute for department or not. The second part of this statement number 2 is a particular employee who manages the department. So we can put it as an attribute for the department as manager. Okay, manager can be an attribute for the department. But here what happened is, this is the company database, isn't it? The employees means we need to keep track about the information about the employees. So that means employee, we can't put it as an attribute. Okay, because manager is going to be an employee, isn't it? So we can't put such thing as an attribute. So as much as possible, this means try to identify which one is going to be the attribute and which one is going to be the entity. So employee is going to be another entity. Okay, so this is another entity that we just identified. So employee is going to be the second entity type. An employee who manages the department. That means this employee is going to manage some employee, means a particular employee is going to manage the departments, isn't it? So that means this particular employee is going to manage the department, means there is going to be this manages. This particular term, this word manages, represent a relationship between the employee and the department, isn't it? So I have already mentioned you that we are going to identify the entities and their attributes, and after that, let us try to identify the relationship. So just leave this thing here, and let us try to identify the attributes, and is there any other entities, any more entities left or not. Okay, so just keep this as like this. We will identify the relationship later on. Let us read the third statement. Keep track of the start date when that employee began managing the department. That means keep track of the start date when the employee, that means the manager of a particular department, began managing the department, isn't it? That means this start date is the start date of the manager managing the department, isn't it? So from here, from this statement, you can conclude that the start date is not going to be an attribute of the employee and is not going to be an attribute of the department. It should be an attribute for the manager's relationship. Okay, so that's why I will keep this statement as it is. We will identify these things later on when we start identifying the relationship between the entities. So we'll keep it like this, because this is not an information about the entity type employee or the entity type department. This is some other information, okay, which is related to both the employee and the department. So we'll skip this statement for now. Let us read the fourth statement. Department may have several locations. So department may have several locations. So location is going to be an attribute. Location is going to be an attribute for the department entity type. Okay, again, you can say that location can be it can also be represented as an entity. Okay, but for this, for now, you have to use your own common sense also. Okay, use your common sense. Okay, so we do not keep the employee as an attribute, because we need to keep track the information about the employees working in the department, working in this company database, isn't it? Because we are going to design the company database. Locations means we do not need to keep track about the different locations of a particular city, isn't it? Because this is a company database, it means this location, we do not need to keep track about the locations. So we'll just keep it as an attribute about the department, for the department. Okay, so like this, you need to analyze the statements requirement specification thoroughly, and while analyzing it, while reading it out, you have to use your own technique to means uh, the technique that I'm using here, and also your common sense in means the real life happening, whatever happening in our real life, you have to use those things, those this one concepts about the real life, and you need to try identifying the entity types, attributes, and the relationship. Okay, so the location is going to be another attributes for department, and at the same time, what happened, location, several locations, isn't it? Several location means it is going to be a multi-valued attribute, isn't it? It is going to be a multi-valued attribute. So we will represent it while drawing, means while representing it using ER diagrams, we will represent it as a multi-valued attribute for this particular location. Okay, for now, just keep it like this, because this is just a rough means I'm just writing the whole things roughly here in this particular slide. So you do not need to represent everything here, because we can't represent the multi-valued attribute here in this way of representing entities and the attributes. Okay. Okay, now the third means the fifth statement, a department controls a number of projects. Okay, here a department controls a number of projects. Again, projects is going to be something which is related to the company. So project, we can identify it as another entity type. So we will identify it as another entity type. Okay. A department controls a number of projects. Means controls is going to be a relationship between department and project. So we'll see it later on. Project has unique name, unique number, and a single location. Okay, so it will have three attributes: name, number, and location. Project name, project number, and location. I will, yeah, location of the project. So here, this location is going to be single value, isn't it? As it is mentioned here, it is going to have a single value. So for now, we have with this six statement. Let us continue analyzing the requirement specification. Employee has name, social security number, address, salary, sex, and birth date. So this whole thing, the whole thing that it is mentioning here in this particular statement, they are going to be the attributes for the employees, isn't it? So name, social security number, address, salary, sex, and birth date. So employee name, social security number, SSN, salary, address, sex, and birth date. Address, salary, sex, and birth date. Okay, I will keep it open for now. Birth date. Okay, so this is done. Let us see the next statement. An employee is assigned. An employee is assigned to one department but may work on several projects. So these are going to be relationships. Means employee is assigned to one department means there is going to be a relationship between the employee and department, and again, but may work on several projects. Again, there is a relationship between employee and project. Okay, so we'll see it later on. Let us see the next statement. Keep track of the number of hours per week an employee works on each project. Again, this is related to the relationship between employee and project. So we'll keep track of the direct supervisor of each employee. So here, see, supervisor of each employee means supervisor is going to be another employee, isn't it? So there's going to be a relationship between employee and employee, isn't it? So what does this kind of relationship call? Anybody? Relationship between means a single entity type participating in a relationship twice.
One to many.
Hmm?
Ma'am,
Yes.
ma'am, can you repeat once?
Relationship between means an entity. Means an entity participating in a relationship twice. It is a relationship between itself. There is going to be a relationship between employee and employee.
Is it recursive?
Yeah, it is recursive. It is a recursive relationship. So there is going to be a recursive relationship. Okay, good. So there is going to be a recursive relationship between employee and employee because supervisor is also an employee, isn't it? So keep track of the direct supervisor of each employee means there will be a relationship between, means there will be a recursive relationship between employee and an employee. Okay, one is going to be supervisor, another one is going to be the supervisee. Okay, the person who is supervising by the supervisor, isn't it? Let us see the next one. Keep track of the dependents of each employee for insurance purposes. So keep track. We are going to keep means we are going to save the information about the dependents of each employee. Okay, for insurance purposes. That means dependent is going to be another entity type. But what happened is dependent is not directly related to the company. Dependent is related to the company using the employee entity type. That means dependent is going to be, we have to identify it as a weak entity type. Okay, so the last entity type is going to be dependent entity type. Okay, from the next statement, let us see dependent has first name, sex, but that relationship to the employee. So what relationship he or she has with the employee. These things we have to keep track. Means we have to set this. We have to keep track about this informations. Name of the dependent, sex of the dependent, birth date of the dependent, and what relationship he or she has with the employee. So these things are going to be the attributes for the dependent weak entity type. Okay, name, sex, birth date, and relationship, isn't it? Name, sex, birth date, and relationship to the employee. Okay. So other things, if means if attributes are not mentioned, there might be some requirement specification where attributes are not mentioned. That doesn't mean the entity type doesn't have any attributes. So I am again saying you have to use your own logic, your own common sense, and you need to provide some attributes which will be using to define the particular entity type. Okay. So for example, if this is not given, the attributes for the department, these things are not given. Okay, but there is going to be an entity type department. In the requirement specification, there should be an entity type department that is given, but the attributes about the department is not given. Then you have to use your own common sense. What type means what attributes we can give to this department. You have to think about it, and you need to give it here. Okay. Sometime what happen is students when the attributes are not mentioned in the requirement specification, they just keep the entity type alone without any attribute. That does not happen. That is wrong. Okay, means there shouldn't be any entity type which does not have any attributes. So if there is an entity type, then there should be some attributes defining the particular entity type. Okay. So make sure you have at least one attribute for the particular entity type if the attributes are not mentioned in the requirement specification. But in this case, for this company database, everything is mentioned. So we have already given the required attributes for each and every for each and every entity types. Okay. So let us close this parenthesis. Okay. Now, what the next thing that you need to do is we have already identified the entities and the attributes about the entity types. Okay, so from here, what you need to do is you need to identify means you need to select a particular attribute which can be key attributes for each and every entity type. You have to identify the key attributes. Okay. For this department entity type, you can use the department number and department name as a key attribute, isn't it? Department name, there can't be in a company, there can't be two departments having the same name. We already know the definition of key, isn't it? Key is a particular, it can be an attribute or a group of attributes which can uniquely identify the entities, isn't it? That means department number is also unique, Department name is also unique. You can use any one of them as a key. For now, I will use department number as a key, and the key attributes are represented by underlining the name of the attributes. Okay, so we'll underline it. Same thing for employee. Again, I will use this SSN as a key. We already know why. Because SSN is going to be unique for each and every employee, isn't it? It can be used to uniquely identify the employees. So we can use SSN as the key. We can't use name of the employee as the key. Why? Because there might be some employees who is sharing the same name, isn't it? So we can't do that. Address can't be the key, salary can't be the key, sex can't be the key, but that can't be the key. Okay. So you have to think about some attribute or a group of attribute which can be used to uniquely identify the employee. Sorry, the this one, the entities. Okay. Now for the project, again, project name, project number, you can use any one of them. I'll use the number. And then for dependent, as dependent, I told you that dependent is the weak entity type, isn't it? So they are not going to need any key attributes. There will be a partial key. Okay, so I'll use the name as a partial key. You can use any of them, but here you can't use sex, birth, death, and the relationship. They can't be used as a partial key. So use means there may be some dependent who is sharing the same name, but still from all the other remaining attributes, name is going to be the possible partial key. Okay, so I'll use it as a partial key. So partial key will be represented by underlining it by dash line, but we can't represent it here. Okay, so I'll keep it like this. So here, yeah, here, see. Here we have identified the entities: department, project, employee, dependent. Dependent is a weak entity type. And means we are designing using ER models, isn't it? So we have to represent it using the notations of ER modeling. Okay, so using the notations, department, it will have name, number, and location. Here, name and number, the combination of name and number is using as a key. So that is why name and number are underlining here. Okay, so you can do this like this also. Means name is also a key, number is also a key. Name can uniquely identify the departments. Number can also uniquely identify the department. So both of them are keys. So the combination of name and number is using as a key here. Okay, you can do like this also, or in the other way, what I have done in the previous slide, you can do like that also. Okay, and location, as as it is mentioned in the requirement specification, that it is a multi-valued attribute. So it is represented by double this one oval. Okay, so this is your department entity type with its attributes. The next one is project entity type with its attributes, so name, number, and location. We already identified these things, isn't it? Then we have the employee. Here one thing, we have the multi-valued attributes, but we do not have any composite attributes, isn't it? So I'm just means using this name attribute, means I'm just representing it as a composite attribute. Okay, this is something that is not mentioned in the requirement specification, but I have added. You can do the same thing. You can add as many information as you can. Okay, if it is not added in the requirement specification, and if you think it is required, then you can add the attributes. Okay, so I'm representing the name as a multi-valued, composite attribute, and the subparts of the name is first name, middle name, and last name. Okay, and we have the SSN, address, salary, sex, and birth. That we already identified these things, isn't it? And SSN is the key attribute, so it is underlining. Can you see whatever I'm explaining here?
Yes, ma'am.
Okay. So the last entity type is dependent. So as it is a weak entity type, we will double means we'll represent it by using double rectangle. Okay. So it is a weak entity type. And dependent name is using as a partial key. So dash line, we have to underline it using dash line. We have sex, but that relationship. This we already identified, isn't it? Now we have identified the entity types and the this one, entity types and their attributes. Now let us go through the requirement specification again, and we will identify the relationship. Okay. The company is organized into departments. Here nothing is mentioned about, means we can't, means there is no relationship to identify from this statement. The next statement, department has unique name, a unique number, and a particular employee who manages the department. So there is a relationship here. I will name it. You can give any name. Okay. But according to the requirement specification, I will name it as manages. The first, the first relationship is manages, and it is between employee and department, isn't it? A particular employee who manages the department. That means it is between employee and department. So whenever we identified this one relationship between entity types, you need to identify the participation constant and the cardinality ratio for the relationship type. Okay, so manages, it is between employee and department. And from here, statement, let us read it again. A particular employee who manages the department means an employee, a single employee is going to manage a single department, isn't it? Means one employee can't manage two department, and again, and one department cannot be managed, means one department cannot be managed by two employee, and one employee cannot be managing two department. Okay, two or more department. That means the cardinality ratio for manages, what will be the cardinality ratio, anyone? It will be 1:1. Okay, it will be 1:1. That means one employee is going to manage one department. Okay, so from this side also it is one. From this side it is also means it is one. You getting it? It will be 1:1. One employee managing one department. One employee cannot manage two or more departments. Okay, if he means a manager can manage two or more departments, then it is going to be 1:n. Okay, but here one employee can manage only a single department. Okay, again from this side also, from department's point of view, again see, a single department cannot be managing by many employees. It has to be managed by a single employee. Okay, because of this statement, a particular employee who manages the department. Okay, that means it should be, the cardinality ratio is going to be 1:1. Okay, what about participation constant? For participation constant, all the employees are not going to be manager. Only some employees is going to participate in this managers relationship. Okay, only some employees. So it is partial. It is partial from this side. Okay, from employee side, it is partial. Means all the employees are not going to participate in this managers. Okay, but from from department side, again, let us read the statement. A department has unique name, a unique number, and a particular employee who manages the department. So every department is going to have a manager, isn't it? That means all the departments are going to participate in this particular relationship type. So from here, it is total. Okay, so this is the cardinality ratio, and this is the participation constant for managers relationship type. versus a relationship type between employee entity type and department entity type. Is that clear? Any doubt? You need to respond.
No
You
doubt,
need to
ma'am.
respond. Okay. Okay, then let's continue if you are clear about it, because this is very important. For every relationship type, we have to identify the cardinality ratio and the participation constant. Okay. Okay. So as we have identified these things, we will read the third statement. Keep track of the start date when that employee began managing the department. So this is, I have already told you, this is going to be a attribute and an attribute for an relationship type. So manages has a manages has a attribute start date. Okay, because this is the start date of the manager managing the department. Okay, so we can't keep it as an attribute of an employee or as of a department. We have to keep it as an attribute of the managers. Okay, because this is something which is related to both the employee and the department which is managing by the employee. Okay, so it should be an attribute for the relationship type managers. Now let us see, department may have several locations. We do not need to do anything for this. A department controls a number of projects. So controls a number of projects means there is going to be another relationship type. I will name it controls. Okay, and it is between what? Let us read it again. I forgot. A department controls a number of projects. So it is between control department and project. It's between department and project. Okay. Now let us read it again in order to get the cardinality ratio and participation constant. A department controls a number of projects. Means a single department can control many projects. Okay, but again here we have to use common sense. A single project cannot be controlling by many departments. Okay, that means from this side it is 1 and from this side it is going to be n. So the cardinality ratio will be 1:n. Department. A single department can control many projects, but a project can be managed, a project can be controlled by only a single department. So 1:n. What about participation constant? Participation constant, nothing is mentioned here. A department controls a number of projects. So we can guess, we can use again real life things, whatever happening, and we can guess the participation constant. So let us see what I have done here. So we can do the same thing, partial and total. Okay. Okay, so from department, I'm just assuming it is partial. You have to do some assumption also. Okay, here. So department partial participation means, it means all the departments are not controlling some, means there might be some department which is not controlling any project. Okay, means there might be some department which is not participating in this controls relationship type. You can also put total here. So this is just an assumption because nothing is mentioned in the requirement specification. So you have to do like that also. Okay, if the requirement specification is not enough to design the particular database using ER model, then you need to do some assumption. Okay, so partial, and from project side it is total. So obviously it is going to be total, means if there is a project, then every project needs to be controlled by some department, isn't it? So project can't stay alone, means there can't be any project which is not controlling by some department. So it is total from this side. Okay, so this is the second this one, relationship type. Department controls a number of projects. Project has, so we do not need, means there is nothing mentioned here. So there are no attributes for this relationship type. I will tell you something here. Entity types cannot stay alone, means entity types should be defining by some attributes. It should have some attributes, at least one attribute. Okay, defining the entities. Okay, but relationship type can have attributes and it can also have no attributes. Okay, there might be some relationship type which does not have any attribute. So like that, controls this controls relationship type does not have any attributes. Okay, because nothing is mentioned here. And if nothing is mentioned here, we do not need to provide any more attributes for the relationship type controls. Okay, it is not necessary. Whatever necessary things which is not mentioned in the requirement specification, you need to do some assumption and you have to provide it. But if it is not required, if it is not necessary, then you just keep it like that. Okay. So that is the second relationship type. Let us see the other, means let us try to identify the other relationship type. Employee has, we do not have anything here. An employee is assigned to, okay. An employee is assigned to one department but may work on several projects. Okay, means employee is assigned to one department. Means if there is an employee, he or she should be working for some department. Okay, but may work on several projects. Okay, so here we can identify two relationships. The first one is between employee and department. The second one is employee and project. So the first relationship, I will name it as works for, and the second relationship, I will name it as works on. Works for and works on. Now let us try to identify the other informations about this relationship. Works for is between employee and department. Okay, and works on is between employee and project. So an employee is assigned to one department but may works on several projects, not necessarily controlled by the same department. Okay. So an employee is assigned to one department and a department can have many employees, isn't it? So this is common sense. So what will be the cardinality ratio? Cardinality ratio is going to be n is to 1, isn't it? And this is for works for. Okay, and participation constant, if the employee if there is an employee for a particular company, he or she should be working for a department, isn't it? So it is total from this side, and again same thing from this side, it should be total. For sure about this, isn't it? Let us see for this works on, employee and projects. So employees and project employee can work for many projects. Let's see whether it is mentioned here or not. May works on several projects. Yeah, an employee might be working on several projects, and a project, for a particular project, it might have many employees working on it, isn't it? So it is going to be N is to M. Okay, coordinated ratio. Participation, there might be some employee who is not working on a project. Let us see whether it is partial here. Let us identify it as I have already done here. Okay, works on, it is total from, yeah, from employee side it is partial, because there might be some employee who is not working on a project. So it is partial from this side, but this side it is going to be total. Okay, so we are doing some assumption according to the real life things, what is happening in the real life. Okay. Okay, so that is done for works for and works on. An employee is assigned to one department but may works on several projects. Keep track of the number of hours per week an employee works on each project. So this hours per week is going to be an attribute for works on. Okay, so works on has an attribute hours per week. Track of the number of hours per week an employee works on each project. So it is going to be an attribute for the relationship between employee and the project. Okay. Keep track of the direct supervisor of each employee. Again, we have identified another relationship type here. So the next relationship type is let us name it as supervise. Okay, and it is between employee and employee. It is between employee and employee. Okay. So if it is a recursive relationship type, then I told you that we need to give the role name, isn't it? The role name. So the role name for a particular employee is going to be supervisor. It is said from the left. The left employee means the employee that I'm writing here is the supervisor, and the employee that I'm writing here is the supervisor. The employee who is supervising by this particular supervisor. Okay. So keep track of the direct supervisor of each employee. Okay. So a person can be supervising many employees, isn't it? So there is nothing is mentioned. So I'm just assuming it as 1 is to n. From supervisors, it will be 1, and from supervisee, it is n, because a person, a supervisor, a single supervisor can be supervising many employees. Okay. And from this side, supervisor side, all the employees can't be supervisor, isn't it? So it will be partial from this side. And again, as it is a recursive this one relationship type, from this side again it will be partial, because some of the employees are supervisor and some of the employees are supervisee, isn't it? So again it will be partial from this side. Okay, anything else? Keep track of the dependents of each employee for insurance purposes. This one, as it is a weak entity type, as dependent is a weak entity type, there is going to be a relationship between dependent and employee for sure. And that relationship type is the identifying relationship type. And employee is going to be the identifying entity type, which is identifying the dependent weak entity type. Okay, so let us also identify the relationship between the weak entity type and the strong entity type. Let us name it as depends. Let's see what was the name that I've given here. Dependent of. Okay. Dependent of. I'm giving this name dependent of, and it is between employee and dependent. It is between employee and dependent. It is between employee and dependent, and coordinating ratio, I will assume I have to do some assumption here. An employee can have many dependent, isn't it? But a dependent is going to be depending on a single employee. Let us assume it like that. Okay, so it will be 1:10. And participation constant from employee side, it is, let us say, partial. It is partial. Okay, because all the employees is not going to, there might be some employee who is not having, means who doesn't have any family member. So for that, those case we need to put it as a partial. Okay, and from the dependent side, it is for sure it is going to be total. Okay, so this is the identifying relationship type for the weak entity type dependent. So we have done identifying everything. We have identified all the entity types and we have identified all the relationship types. Let us see it again. So these are the entity types and their attributes, and these are the relationship type and the information about the relationship type. We have manages. It is between employee and department. 1:1. Partial total. This we have already done. Controls we have already identified. Works for we have identified. Works on we have identified. Okay, supervision we have identified, this is between employee and employee, supervisor supervisee. Okay, dependent of, this is identifying relationship between employee and dependent. 1:n, partial total. So as we have identified everything, let us draw the ER diagram for this particular example. So we have employee SSN, but that name is a composite attribute. So we everything here we have to collect. We have means we need to uh, we have to represent everything that we have identified here using the ER model, isn't it? Using the ER representation. So employee, we this is going to be the attributes and the entity type employee. Department we have here, project we have here, and dependent we have here. And the relationship, it should be represented by the diamonds, isn't it? So works for, as it is total from this side, it is double line. We have joined it using double line. We have joined it using double line. So from this side also it is total. From this side it is also total. So total. So double line. We are joining it using double line. And the ratio is from employee side it is n. From department side it is 1. So n:1 or 1:n, whatever. Okay. Employee and department, there's another relationship type, managers. Managers has a this one uh, attribute start date, isn't it? And it is partial from employee side also, and from department side it is total. Okay, 1:1. Here number of employees. This is just means additional attribute. Okay, that we haven't identified here, but still you can put some assumption, you can use some assumption, and you can put some information if it is required. Number of employees, and this can be derived, this can be derived from the means from other some other attributes. Okay, so that is why it can be derived, it is a derived attribute, it is represented by this dash oval. Okay, number of employees, it can be derived by using this relationship also, works for, and the person who is working, and the department means by using this relationship works for, you can derive this number of employees. Okay, you can count the number of employees working in the department and you can put it here. So that is why it is a derived attribute. It is representing as a derived attribute. And we have controls here, department, between department and project. 1 is to n, partial from this side and total from this side. Okay. Works on is between employee and project. M is to n, total from this side, total from this side. And this is the hours per week that we have identified in the previous slide, isn't it? Supervision is here from this side, the role names. The role names we have to write in here. Okay. So supervisor and supervisee. So this is partial and also this is partial. 1 is to n. From supervisor it is 1. From supervisee it is n. So 1 is to n. Independent of, this is the identifying relationship type. Okay. So 1 is to n. So this we have already done. It is already 2. Do you have class at 2 p.m.?
Not today, ma'am.
Okay. Okay, then this is the overall ER diagram for the company database. And this whole thing, the whole thing is representing the big, means the overall entity type company. Okay, you can't represent it here. Means the company can't be added here as an entity type, because this whole thing, the whole thing that we have represented it by using the ER diagram, it is representing the company database or the company entity type. Okay. Any doubt?
Ma'am, I have doubt in recursive relationship. Can you please explain it once?
Recursive recursive relationship is a relationship, means it is a relationship where the participating entity type, means the same entity type is participating twice. Okay, so those relationship type are known as recursive relationship type.
Ma'am,
Here you
many
can see this is a relationship type. Supervision is a relationship type, isn't it? And the participating entity is employee. It is employee is participating twice here. So that is why it is known as recursive relationship. Okay.
okay.
Even from the requirement specification also you can see keep track of the direct supervisor of each employee. You know that supervisors are also going to be employees,
Yes,
isn't it?
ma'am.
So supervisor of each employee. So that means there is going to be a relationship between an employee and other remaining employees, some other employees, isn't it? So that is a recursive relationship type.
Okay, ma'am.
Okay. Any other doubt? So I'll tell you again. You have to go through the given requirement specification again and again. You have to read the requirement specification, analyze the requirement specification in order to represent as a form of the ER diagram all the information that is given in the requirement specification. So anything should not be miss out. Okay, everything as much as possible or more than that you have to identify them, and then you have to represent it as a ER diagram, in the ER diagram. Okay, we'll do the same thing again using another example tomorrow. Okay, then response your attendance. Abhijit, Anand,
Present, ma'am.
Akash,
Present, ma'am.
Atul,